So here I am presenting my final project, which is done on the building project that I actually created in the ETAP software. So here I have minimized my mat footing, and you can see these columns. There are 16 columns which have actually the dimension that I took when I created the building in the ETAP software, and there only I collected the data of the base floor columns and the loads they are bearing. Basically the dead loads and live loads I have taken under consideration, and after taking the values under consideration, after I used the grid only view and then created the mat footing. I used 18 grids, 18 grid lines in X direction and 18 grid lines in Y direction. Then by going to edit, now my then actually locked because I have already run the analysis. So I am just showing you the procedure which I followed the drawing of this footing. So I went to edit, then clicked on edit areas, and there I expanded the area by 2 meters. So here I got a total of 22 meters with length and width mat footing. So then I defined these slab properties, coarse material properties that were used in the building design, and they are M40 concrete grade and HYSD 415 rebar grade. So then I defined these slab properties. I used subgrade modulas of 3 into 10 to the power 4 kilonewton per meter cube, as my soil bearing capacity is 300 kilonewton per meter square and allowable settlement is 1 centimeter. So by putting in the formula as say bearing capacity by allowable settlement, I got 3 into 10 to the power 4 kilonewton per meter cube subgrade modulus. So then I defined the column properties. I added there are two types of column you will find here, which are having dimension of 500 into 500 and 600 into 600. So then I assigned the loads for each and every columns by putting the values that I have already noted down from the building design, especially taken from the base floor. So each and every column is assigned with the load. You can check here the loads. Here you can see that at this column, particular column, dead load of 1000.6 is applied, and a live load of 438.9 kilonewton is applied. So similarly I applied loads in each and every columns. So here you can see that dead load is 2752.1 kilonewton and live load is 1300.3 kilonewton. So dead load is distributed in each and every column here, as well as live load also. So I defined this rebar material of this design strip as HYSD 415. Here you can see 1, 2, 3, 4 design strips in X direction. It is named as A, and I changed the rebar material to HYSD 415. Similarly in case of B, that is the design strips in Y direction, also named as rebar materials are named as HYSD 415. So after that I ran the analysis by clicking on run analysis, and then I clicked on run analysis and design. So now I can click on a show punching shear design. So you will see that each and every values are below 1. That is why I can say that my design has not failed the punching shear, that is, it has passed the punching shear. So I can click on show tables by expanding concrete design, then expand concrete slab results, and check table concrete slab design 1. Now click OK, and you can see the status here. So you can see the status text as okay, so my design has not failed any flexure and shear failure. So it has passed, and so click OK, done, and you can display the various results outcomes, like I can see the slip forces. So here you go to click movement, layer A and layer B, field diagram, show failures, apply, click apply. So you can see the diagram, and you can toggle between the each and every strip lines to see the failures changing. You can see that. Yeah, you can go to this design strip, and you can go vertically, changing the design strips also. So similarly, you can check for shear force and click apply, and see the diagram like this. So like that you can navigate between one column to another column, and you will you will see the change in shear force. So that's all. And then you can check the slab process stresses. So here I am going to check for maximum bending moment. So click apply. So bending moment is here under 10 to the power 3. So you can see the maximum bending moment in these zones. The color variation is shown here, and you can check for maximum shear force. So you can see the change in color in the color status bar. The various values are indicated here. So here you will see that the red zone in the color bar is showing that the value of maximum shear lies between 0.25 to 50 into 10 to the power 3 kilonewtons. So here the values are like that only. See, 367.32, then gradually increasing. Here is also the values are gradually increasing. So like that way you can check your results. So you can see the 3D view also. So here click on 3D, and then click on extrude view. So click OK. First I need to cancel this. Okay, so click on XY and cancel the extrude view. So you can check other details also here. You can see the crack width here. So slab bottom face, click apply. So you can see the crack values are in 10 to the minus 3. So these are very less, so we can ignore also. So click on slab top face, click on apply. You can see the crack values are very less, so you can take under consideration. You can ignore them. So you can change load combination here also. Load combination to and click then apply. Slight change in the crack values, but these all are very less. So you can go to display. You can do that. Go to detailing, and you can see the list of drawings here also. But first let me go to run the detailing. So check all these options and then click OK. So here you can see my footing showing the various details, and here you can check the drawing sheets like cover sheets, and here is my drawing data. and you can shade the river shape also. So go to in display, strip process, reaction process. You can navigate between the various kinds of results to check them. And now so basically we have done the complete as analysis part and check the required data, and so now you can see the extruded view, that is 3D view of my footing. This is the matte footing, and these are the 16 columns showing the various punching shear value, shear ratio. So all are falling under 1. So that's how I can design my footing. So cancel the exclude view, uncheck this, click OK, and then move to XY plane view. So you can go through the detailing part and check each and every details we have to take under consideration during the design of the footing. So that's all. Thank you.